I've been in Hanover all week at the Messe. It was a tremendous experience. There's so much going on right now in technology, in industrial data architecture. So I'll try to speak clearly, but it's been a long week. I wanted to start off by asking, how many people here are from OT? Raise your hands. And how about people from IT? Okay, so a couple of things. One is, right, and how many people here, their organizations have converged them, or we no longer really have that distinction because it's really, we're kind of working on both sides now, and we're interacting with both. So yeah, we have some of those as well. It's fascinating times in our industry. It really is. And in fact, industrial data architecture, if you did some Google searches and looked at history, it probably didn't even exist 5 years ago. And yet today we've got a room of, 80 people, 100 people here, and we've got a number of people online who are all here interested in learning about it because it's rapidly changing. We have a great partnership with Amazon Web Services. Some of the things that you're able to do with cloud storage and cloud compute and cloud processing is just tremendous and is able to change our businesses. But the challenge is we need to change our architectures to get there, and that's what we're going to talk about today, and that's what I'm excited that people are here to listen to. So as Anders, it's so convenient. You just have to say Anders. As Anders introduced me, I'm John Harrington. I'm the Chief Product Officer of HighByte. So a little bit about HighByte. We're a software company. We're focused on manufacturing and industrial companies who are going through digital transformation, okay? And we're focused on the data piece of it. And we recognize that there are many challenges working with data and that we need to take a much more systematic view of how we think about data and how we map it and move it across our enterprises. And this is what industrial data ops is all about. And so I'll get into more details of that, but that's really the premise. Now the HighByte team came from a very industrial background. Many of us have been in the industry for many, many years. And so we really understand industrial data. Many of us worked for Kepler Technologies for many years. So we know that deep PLC interaction and data and the structures, but we also know where the data is going and how it's being used. The SCADA system, the MES system, the CMMS system, and now the cloud and all the things that we're trying to do with it. So we have a number of customers across the globe. Yichin said that they had distribution centers in, 6 continents? 5 continents. We have customers in 6 continents. You probably do too. The last continent is really challenging to get to. But really focused on industrial companies. Broad range, across a broad range of manufacturing verticals. So it's not just process or it's continuous process. It's not just batch, it's not just discrete. It's really across all of them. There are common problems and challenges across all of them. There are unique challenges across each one of them as well, but there are common challenges, and the biggest one is how do we work with our data and how do we move it effectively? So when we talk to customers, we often hear, we've started pilot projects. We may have even started deploying it, so it's beyond a pilot. We tried to scale it out, and we're struggling. There is massive volumes of data available today, and I can tell you it's only going to grow. It's grown tremendously in the last 5 to 10 years. It's going to grow even more over the next 5 to 10. We can move, and this is what often happens with pilot projects. We set a team on it. They extract the data that they need. They pull it up. They bring it into the cloud. They start running through some analytics, and they say, here's a great project. We can really save some money, or we can improve our yield, or we can drive business value for the business. But then they say, okay, great. How do we scale that out? What does that look like? And they start to look at it and they say, well, the way that we just executed that pilot doesn't scale. It was very manual. We had to go down, we had to extract it from this data set, extract it from that data set. We had to manually massage that data and work with it, and then we ran it through. And so the key is we need to figure out some way of scaling. So we've got lots of data. There's definitely still a divide, although I think a number of people here are starting to see those barriers being broken down. But between OT and IT, there's not only a personnel divide or departmental divide, there's also, for good reason, network divides, right? ISA 95 has identified that we need to create structures around the controls network that separates it from the IT network, separates it from the cloud and the whatnot, so that we can secure things. On the other hand, there are also practices that enable us to move data efficiently and securely through them. So we need to figure all of this out between the OT and the IT and move data effectively and be able to do this at scale. But it's not just about moving the data. A lot of it is about the contextualization of the data. And I would argue that this is actually the biggest problem. So it's not about protocols. People talk about protocol wars, and over the last, I don't know if you guys are online, if you're on LinkedIn or you're on the Discord, over the last 6 months to 12 months, has blown up about protocol wars. We've got MQTT, we've got Sparkplug, we've got OPC, we've got REST, we've got databases and MES, and it's not about the protocols, it's about the data. And this is where we need to get to. We need to fix the data problem. So I put this up because if you all look here, I would argue everyone in this room, I would argue our spouses and our kids would understand what this payload right here is saying. And if you read through it, you understand it. We're collecting data on a pump. It's in a brewery. We know the location of it. We're collecting the power consumption. We're collecting the pressure. We know who the vendor is. This is a great data set for us to read. This is a great data set for a dashboard to be able to rapidly interpret. So like Power BI or Tableau or Grafana, you could take this, you could instantly flash it up. If you did this across all your pumps, you would have to build it once, and every single pump you could have its own unique dashboard, and you could do that very fast and very quick. You could put AI on this, you could put generative AI on this, and you'd have no hallucinations. It knows exactly what it's talking about. The problem is our industrial data looks more like this side on the right side, or your left, my right. We have PLC data. We then purchased some Monitron sensors from AWS. We put them out on the motor so that we could check out the temperature or the vibration. We've got a CMMS system. And it takes all that data, combining it together to create logical payloads like this that we can use effectively. And there are a couple of steps here. First, we need to contextualize the data, and then we need to contextualize it into payloads to establish the relationships. Now, I'm also showing 2 PLC data tags. There's only 2 PLC data tags in this whole thing, telemetry tags, in addition to the temp sensor. Your factories, chances are, have over 1 million PLC data tags. If you were to go to every PLC and scrape it, in fact, I would argue that a modern day Siemens or Rockwell, Mitsubishi PLC, if you were to pull every single data tag off, you would have over 100,000 on every single PLC. So you can't say, I want all the data. We need to get beyond that. We need to say, we need to collect data for purpose, and we need to move it for purpose. And that's also what Yi-Chin was talking about. So it's critical to be able to figure out how to do this at scale. And it's that combination of connecting the systems efficiently, it's doing that contextualization, and then having a platform to be able to manage and maintain this over time that we see as industrial data ops, and creating a practice around it. So it's more about the practice around it that combines both OT and IT and business functions. It's about bringing together various processes. A lot of these processes have been on the IT side for a long time, but they haven't been on the OT side. We've managed OT much more like very project focused, very project centric. We bought a new machine, we need to deal with that. We bought a new MES, we need to deploy that. But it's not kind of a holistic architectural view. We need to take that. We need to define some data contracts. We need to define semantic data definitions, as Yi-Chin talked about. We need to do data engineering. And then we need technology. And we need technology to orchestrate the data. That's moving it, contextualizing it. We need to provide high quality data. And industrial data quality is not just about is it correct or is it wrong? In fact, we're pulling it from machinery. It's almost always correct. It's about having consistent data. There's certainly, is the value right, but there's also, is it consistent and is it usable? That's what data quality is in the industrial space. We need to provide observability. What's going on? I'm now moving data to the cloud. I'm moving data to the edge. I'm pulling data out of the cloud and moving it back to the edge so the operators know who the customer is of the order that they're working on. So I need observability of that data passing all over. This has become a data mesh or data fabric or a data network. And we need governance over that. We can't just have anyone go in and change it, but we need to provide some autonomy to the sites. We need to provide some governance by the enterprise, depending on how we're using the data and for what data sets. And that's what we see as industrial data ops, the ability to pull all this together. The next thing I want to talk about is unified namespace. This is a huge concept in industry right now. A lot of people are talking about it. A lot of people are talking about it at Hanover. A lot of people are talking about it online. To some people, it feels like magic. We don't really understand it. It's very vague. To me, it's extremely logical and relatively basic, but it's important. Okay, first thing, the term unified namespace. A namespace is just the structure of the target system. So in a database, the namespace is the table and the columns. In an MQTT broker, the namespace is the topic paths and the payload. In OPC, you've got the data model and the data tags. So it's not that complex, but then we need to unify it, and that's where the interesting bits come. That's where the interesting piece comes. We need to pull all the data together. We need to standardize that data. We need to make it available to people or to systems who need that data. And that's where the power of unifying it comes. And so we need to build payloads. Now, one of the key ways that we're creating unified namespaces today is through MQTT brokers. And the broker does a couple of things that are pretty interesting. And MQTT is a protocol that make the unified namespace very powerful. It's got this topic path which enables you to organize your data. So it's a very logical organization of information for a business because ISA 95 built this hierarchy as part of the spec that is very logical to anyone who's worked in manufacturing or even worked in a business. You have the company, you have the site, you have the area, you have a line, you have a work cell, you may have an asset, you may even have a sensor, but organizing data in that structure makes a lot of sense. And every company has sites, every site has areas, every area has a line, or it may not have a line, but it may have many cells. Every cell has a series of assets. So it's a very organized view of the data. And so the key is, if we put it into that structure, it's very logical for people who are less knowledgeable about the factory to be able to get access to data. But it's also very logical for people who are in the factory to get access to things like, you may include the profit and loss at the site level. You may include the OEE at the line level. You may include the compliance or quality data at the work cell layer. Quality isn't about the cell, it's not about the asset. It's not about the site. It's about that work cell. Did it produce good quality parts or bad quality parts? You may include predictive asset maintenance data at the asset level. So creating data sets at the different levels based on their use case and how they're being used. So if we think about, well, what does this look like in practice if we break this out? So we have a UNS. and I would argue you also can create this over time. You don't have to roll this thing out by defining the entire namespace for the entire company on day one. That's the beauty of this technology. It's the beauty of technology today. It's very scalable. It's very easy to start small, start getting value, and then grow it over time. So here we've got a conveyor, and we're collecting some production status information on it. We're publishing it into the namespace, and as you can see, now that it's in the namespace, I can now connect up different applications to that data, and we can use it for analytics, we can use it for reporting, for visualization, for storage. And then as we build out and we add more use cases, and I would argue, start with your high value use cases. Only work on the valuable things, but put them in the structure so that over time you're building up this unified namespace. Have the vision. Yi-Chin talked about it earlier. You need to have the vision, or Jeff Bezos talked about it, I think. You need the vision, the North Star, but then you need to get started, and you can start small and work your way up. And it's about defining, standardizing, normalizing, merging the data sets together. And the whole point is that we're driving faster access to data. We're driving faster data integrations. We're bringing systems together, data together to make people available. Now, the other thing about UNS is that a lot of people get really focused on the protocols again. And I say, we can put a UNS anywhere. It can be an MQTT broker. It can be a data lake. It can be a data warehouse. It can be a file for all we really care. But the key is you need to think about the personas and the people who are consuming the data. What systems are they using? And what's the easiest way to get them access to the data? And that's what we're really trying to solve here. We're not trying to just create a unified namespace. We're trying to solve business problems. We're trying to get people access to information so that they can perform their jobs better. This is anything from the quality engineer who's sitting in their office, who works with the IT team, and they are producing a dashboard for the quality engineer to see what's the current status, how many units, bad quality units and total units have we produced on the line in the last shift right now, up until right now, to an operator on the shop floor and we work with a bearing manufacturer relatively close by here, who wants their operators to be able to know who is the customer, how many units are we producing, and where are these units going? Because if the operator, their feeling is if the operator knows that information, they will put more effort into making sure these are good units and that the product goes out the door on time than if it's just you need to produce 50 units today. But if we can say, you need to produce 50 units, and these are for Toyota, and they're going to a car company in Czech Republic, and now all of a sudden it's someone is buying this car, and I need to have good bearings in it, right? So giving people access to data at various levels is critical. So we can put the unified namespace anywhere. And so I think of it as, yes, MQTT is a great tool if you've got consuming applications that can consume MQTT and can create these off of it. But we can also use a data lake. We can use whatever we need. AWS has many different tools that we think of, that we put data into. We can put into SiteWise. We can put it into S3. We can put it into a Snowflake data warehouse. We're starting to see a lot of experimentation with those different applications. So in order to create that unified namespace, in order to create that structured data, HighByte's developed the HighByte Intelligence Hub. The HighByte Intelligence Hub is really focused on industrial data. It's focused on being able to standardize and contextualize data. It takes a hub and spoke approach to moving data. So a lot of people are very familiar with the Purdue model. We're going to move data from the sensor to the PLC, to the SCADA, to the MES. There's too much data today to move it through layers that don't actually need it. And there's too many use cases. Now, you may have a piece of telemetry, like that pump, the power consumption. Now, that power consumption can be used for asset maintenance. That was the use case that I talked about. But that power consumption can also be used for sustainability. We need to know how much power is being consumed by this area of the plant, and it looks like that pump is consuming a lot more than another one. Maybe we should look at replacing it, or maybe we should look at how do we reduce the power consumption. So sustainability could be another use case for it. We could also have quality as a use case. When the defects were created, it looked like our power kept spiking. So there's telemetry has lots of different use cases, but every time you create a use case, you need to contextualize it differently. So we really need to think about how we're creating and contextualizing this data and delivering it. So Intelligence Hub breaks down that hierarchy of moving data up and down the stack, really sits outside of the stack and says, let me grab data as I need it. Let me contextualize that data and move it to where it needs to go. Now, I suspect that probably 85% of the data that's moving through Intelligence Hub across the globe is moving to the cloud. It is the number one target today because it's highly scalable. It's relatively mature at this point in time. And a lot of companies are experimenting with it and working with it to drive value. I think there's going to be a trend over the next 5 to 10 years moving certain workloads down to the edge. And we're going to see workloads running at the edge that were actually, they were set up in the cloud. You may have done the learning in the cloud, but then you pushed it down to the edge to run it. But we're showing arrows that are bidirectional because we can not only push data to the cloud, we can also pull it out of the cloud. In fact, we have customers who are pulling the sensor vendor is backhauling their own data to the cloud. They're pulling it out of the cloud, they're moving it down to an on-prem SCADA or historian so that they have access to what was the sensor value. And the benefit of that is that they're getting and analyzed, they can get like certain predictive metrics off of the vendors. But so there's lots of different directions that data is going, and that's why I see it as a mesh or a fabric. So if we take that broad view and break it down, we essentially create data pipelines, okay? We're creating a pipeline of data. But I always tell people, similar to what Yi-Chin talked about, you have to start with the business problem. To contextualize data takes understanding the business problem because the quality engineer thinks of that power differently and you contextualize it differently than the asset maintenance engineer. And they think of it differently than the process engineer or the operator or the sustainability engineer. So the key is you identify what the use case is, high-level use cases. I'm not talking really specific. High-level use cases, what is the volume of data that we could possibly need for that use case? And then let's go source it. Let's figure out how we need to transform it. Let's standardize it, normalize it, and then let's deliver it. And the delivery, the other thing about these use cases, understanding the use cases, the delivery is always going to be different. If it's a typical SCADA application, we're typically delivering at 500 milliseconds to a second, sometimes 100 milliseconds, but that's typical range. If it's a dashboard for management, it would be typical to do something like every 10 minutes. We want to update that to make sure that's accurate, but they don't need massive volumes of data. If it's predictive asset maintenance of a motor in a paper company, it's a critical motor to run the paper company, and if that motor shuts down, we stop the entire process, we scrap every piece of product that's currently in the entire building, throw it away, it's going to take us 3 hours to restart the process, then we better be capturing very high resolution data. So we have a paper company who's capturing 1 millisecond data. Now they don't need it, this is for predictive asset maintenance, because that motor is critical. They don't need it every continuous. They need 1 millisecond resolution for a 1 second burst every 10 minutes so that they can bring it up, they can run some analysis on it, and they can see if the motors are running well. And they found out that the power quality was a good predictor of something going wrong. It may be something in the windings, it may be something in a bearing, but if all of a sudden we're starting to see weird power blips, then something's going wrong. We need to send a tech down there because it's only going to decay and it's only going to get worse. So the key is identify the problem, identify the frequency, identify the source data, and contextualize and deliver it. And then we need to do all of this at scale. So you need to have various different utilities to templatize things. There is some consistency to some of our data. And some of the data is very well structured. And if we can just pull that out and send it immediately to where it needs to go, that's great. There's other data that's very poorly structured, very poorly defined, and we need to add more to it. So you need to have that flexibility there. And then we need to be able to work with IT. So corporate IT and working with the cloud has access to be able to deploy across all sites. And so now we can orchestrate out of the cloud, delivery to the edge, management from the cloud, so they can see all of the different edge hubs, they can deliver containers, they can monitor them, they can provide access to them. And so it's the IT and the OT working together that's the real power here. HighByte, working with AWS, we support a lot of their different services. We do that because some services are great for one use case and some may be great for another. For instance, a lot of people are sending data to IoT site-wise, and it's a time series database. But if you've got 5 years of historian data, you may want to just land that in S3 because it's very cost-effective, and you'll have a long-term access to it. But you don't need to look at it. You don't need to put it in cold storage and let it be there just in case you need it. At the same time, a lot of people are running data into data warehouses, more of a tabular view of data, and that's great too, and that is very applicable, where you're capturing data every event, say, or once a second I want to capture this entire data set, send it to a data warehouse. That way you can analyze it very easily. A lot of our IT tools and analytic tools today are designed more for tabular data than they are for time series data, but a lot of our OT tools are designed more for time series data. Okay, a little bit about architecture. We've also developed the ability to have one hub that can orchestrate the other hubs. So you can run a hub in the cloud, for instance. You can define your hierarchy, define your structure, define your data models, and then you can move that structure down into remote hubs. They may be multiple hubs in a given site because it's just logical reasoning for doing that. Or you may have multiple hubs across multiple sites, and you can run that data. You could then run that directly into AWS. You could run it into a MQTT broker. You could have individual namespaces or unified namespaces at the edge, at the site, which what we're often seeing is the site wants to have an MQTT broker for the OT team to get access to the data. The enterprise wants it in the data lake or in the cloud, the data warehouse, to do their analysis and whatnot. Maybe 3/4 of the data is common, 1/4 of the data is different between the two, right? Not different, but different data sets. It's not that the data is different, it's that the enterprise doesn't need certain data and the site doesn't need certain data. So, we're seeing a lot of those hybrid architectures in play. Okay, so to wrap up, we really see orchestration of data and contextualization, quality, observability, and governance as the critical components to delivering on industrial data ops. It needs to really understand the challenges of industrial data. Okay, industrial data has unique challenges. We've got telemetry data, we've got transactional data, and historical data, bespoke loggers, all that on the factory floor. We've even got images, and we've got machines that are logging CSV files. I've been shocked at how many machines are still logging CSV files and how many people are using our software to interpret CSV data and mix it with the telemetry data, because it's still a lot of it out there. It turns out it's actually fairly easy, simple, and frequently used. And then we have to think about the enterprise and the personas that we're doing this for. And then finally, we need to think about the business value. And the business value from this is interesting because we're certainly delivering on the digital transformation value. So things like improved uptime of the factory or of the machinery, improved quality, improved yield, reduced scrap. But we're also providing value to the IT and the OT team because we're giving them a platform to manage all of this. In the past, they may have written scripts here. They've got this approach here. They've got a different approach for moving data to the cloud. And certain cloud architectures you look at, and if we're moving SAP data, we're going to do it this way. If we're moving SQL data, we're going to do it that way. If we're moving OPC data, we'll do that. With files, we'll do this. And all of a sudden, you've got 20 different approaches for moving data. And then you have to start in the cloud trying to contextualize it. And the problem is the domain experts that know how to contextualize industrial data, they're in the factory. And they're not data scientists who are working in the cloud. Now, once we get that base level of contextualization on the data scientists can do phenomenal things that we never even thought of, and we don't even know about today, like large language models. And in the future, how can we use them? Well, they'll need a base set of structures of data that they can work with. And that's really what we're talking about doing. So there's the business value, and then there's having that platform makes our IT and OT teams so much more effective. We have a customer in the US. They make contact lenses, and they talk about, they did a predictive asset maintenance project, that pilot, and they figured, this is going to take, it took them a certain amount of time, and they projected how long it would take to roll that out for all their machines in the factory. And they figured it would take them a year to do it the way that they initially approached it. They started working with HighByte, and within 30 days, they had the entire factory rolled out. So we're seeing and hearing stories like that where we're getting a 10x acceleration of our IT and OT teams to deploying projects. And we also talk to people and they say, I've got 50, 60, 100 projects that I could do. And they all have value, but I don't have, the most precious resource today is all of us. The most precious resource is the IT and OT people who know what's going on in the factory and can do this sort of work. So we need to make us more effective so that the business can get the delivery of the data. And with that, I will stop talking. But I'd love to talk to you all in the sessions. If there are any questions or we have time for questions, that's great. I'm going to be here all day until the last person leaves. I'm also available online, LinkedIn, that's my LinkedIn code. But feel free to reach out to me, feel free to email. HighByte has a lot of resources on our website and on our YouTube page and on LinkedIn. So thank you very much. And I guess, I don't know if we have time for questions. You want me to just sit and we'll take them at the end?
Oh, we give John a hand, please. We do have time.
Okay.